On June 11th, 2026, the National Oceanic and Atmospheric Administration confirmed what the ocean had been hinting at for weeks. El Niño had arrived in the tropical Pacific. The warm phase of the world's largest ocean climate pattern was here, and it was still building. If you find these calm reports useful, you can subscribe and follow along as this one unfolds. Here is the part worth a closer look. By the middle of June, the key stretch of the central Pacific had warmed to about 1.7 degrees above normal, and it kept climbing. Forecasters put the odds near 63% that this grows into a very strong event by winter, the kind that shows up maybe once a decade. Some models push further and see the strongest El Niño since at least the 1950s. The outcome that matters most is quieter than any single storm. It is heat. A warm ocean this size tends to pull the whole planet's temperature up along with it. This report walks through how it formed, why it may run so strong, what it could bring, and the one catch that might soften the blow. The announcement was short and it did not raise its voice. The National Weather Service said that El Niño had formed in the tropical Pacific and that an advisory was now in effect. That word, advisory, is worth a plain definition because it carries the whole meaning. Forecasters use a watch when conditions look favourable for something to develop. They move to an advisory once the thing has actually arrived and looks set to stay. So the advisory was not a warning about the future. It was a statement about the present. El Niño was no longer on the way. It was here. What the agency confirmed was simple enough. The surface waters across the central and eastern tropical Pacific had warmed well above their normal range. The air above that water had begun to respond in the way it does during these events. And the warming was expected to keep going, not fade, as the year turned toward winter. None of that sounds dramatic on its own. A stretch of ocean runs warmer than usual, but this particular stretch of ocean has an outsized say in the weather far beyond it. When it warms, the effects do not stay in the Pacific. They travel. Here is why one patch of sea carries so much weight. The tropical Pacific is the largest warm surface on the planet. The heat rising off it helps set the rhythm of the winds and the rain across the tropics. When that heat shifts east, as it does in an El Niño, the rhythm shifts with it. Storm tracks slide. Dry places and wet places trade seats. A change that begins near the equator ends up nudging winters in North America and monsoons in Asia. That reach is the reason forecasters treat the arrival of El Niño as real news rather than a quiet note in a log. It is one of the few things about next season's weather that can be seen coming months ahead. Most of the atmosphere is a fog past a week or two. This one signal cuts through the fog. The agency also said the event should be strongest in winter. That timing is normal. El Niño tends to peak in the cold months of the northern hemisphere, and its fingerprints on weather show up most clearly then. So the version of this event that people will feel is still forming. Early summer is the opening, not the main act. There was one more line in the update, and it is the line that lifts this event above an ordinary one. The warming was not only present, it was strong for so early in the season, and the models expected it to grow. Forecasters raised the real possibility that this becomes a rare, top-tier event by the time it peaks. That is a careful claim, and it is worth holding carefully. Nothing about the peak is settled yet. An El Niño can stall. It can surprise its own forecasters. What the agency offered was a present fact and a leaning, not a promise about December. The present fact is confirmed. The leaning is a forecast, and forecasts carry room to move. Still, the direction was clear enough to act on. Governments and aid groups watch these updates the way farmers watch the sky. Because a strong El Niño can mean a failed harvest in one country and a flooded valley in another. When the world's most authoritative sources agree that the warm phase has begun and is likely to intensify, that agreement itself is the story. So this is where the report begins. Not with a disaster, and not with a forecast of doom, but with a plain confirmation from the people whose job is to watch. The ocean has changed state. The change is real, it is measured, and it is expected to deepen. Everything that follows grows out of that one fact: how the warm water got there, why this event may run so hot, what a strong El Niño has done in the past, and what it could do in the months ahead. And running underneath all of it, a quieter outcome than any single storm, the steady lift in the planet's temperature that a warm Pacific tends to bring. To understand why forecasters are leaning the way they are, it helps to start with the single measurement that told them El Niño had arrived. It is one number, taken from one box of ocean, and it is the number the whole world watches. The number comes from a rectangle of open water in the middle of the Pacific. Scientists call it the Niño 3.4 region. It sits along the equator, roughly halfway between Indonesia and South America, in a part of the ocean with no coastline and no landmarks. There is nothing to see out there but water and sky. Yet that empty box is one of the most closely watched places on Earth. The reason is simple. The temperature of the water in that box tracks the state of the whole pattern better than any other single spot. So forecasters take the average surface temperature there, compare it to what is normal for the season, and report the difference. That difference is the index. When the water in the box is close to its long-term average, the index sits near 0, and the pattern is called neutral. When the water runs warmer than average by 0.5 degrees Celsius or more, and stays that way, forecasters call it El Niño. When it runs cooler than average by the same amount, they call it La Niña. It is a plain thermometer reading, turned into a label. By the middle of June, the reading in that box had climbed to about 1.7 degrees Celsius above normal. In Fahrenheit, that is close to 3 degrees. That may not sound like much. 3 degrees is the difference between a cool room and a comfortable one. But this is not a room. It is a slab of ocean thousands of miles across, and warming all of it by that much takes an enormous amount of heat. Spread over that area, a few degrees is a staggering quantity of stored energy. There is a threshold worth knowing, because the rest of the report leans on it. When the index climbs past 2 degrees Celsius, which is a little over 3.5 degrees Fahrenheit, forecasters call the event very strong. In plain speech, people often call that a super El Niño. Only a handful have crossed that line in the modern record, and by mid-June, the reading was already most of the way there, with the season for growth still ahead. That is why one number carried so much news. It was not just positive, it was high and early and climbing. A reading like that in June hints at something large by winter. It helps to know how the number is actually taken, because it is not one measurement. It is many, blended together. Buoys anchored along the equator send back water temperatures around the clock. Satellites read the surface from above. Passing ships and drifting floats add their own readings. All of it feeds into a single averaged value, checked against decades of records. The index is a consensus of instruments, not a guess. That care matters, because the index is now a decision maker. When it crosses the half-degree line and stays there, and the atmosphere responds, the official label changes. Aid budgets shift. Water managers rethink the year. A single average temperature taken from a box of empty ocean ripples out into choices made on land. There is one honest wrinkle in the number, and it is important enough that a later chapter is built around it. The world's oceans have warmed over the past several decades. That slow warming can lift the reading in the box, even when the El Niño pattern itself is only moderate. So a high raw number today does not mean quite the same thing it meant 50 years ago. Forecasters have started using a second adjusted index to account for that drift. For now, it is enough to say that the raw number is high, and that reading it correctly takes a little more thought than it once did. Set that wrinkle aside for a moment because the plain fact still stands. The water in the box is warm, the reading is climbing, and the label has flipped to El Niño. The thermometer has spoken clearly. But a thermometer only tells you the temperature. It does not tell you what El Niño is, or why a warm box of water in the middle of the Pacific should change the weather half a world away. That is the next piece, and it is the foundation for everything else. Start with the ocean as it usually is, because El Niño only makes sense against the normal picture. Along the equator in the Pacific, the winds usually blow from east to west. These are the trade winds, steady and reliable, and they have been pushing across that ocean for as long as there have been sailors to name them. As they blow, they drag the warm surface water along with them, piling it up on the western side near Indonesia and the islands beyond. That piling has two effects. On the western side, warm water stacks up deep, and the air above it rises and rain falls in heavy tropical downpours. On the eastern side, near South America, the warm surface water has been dragged away, so cooler water rises from below to replace it. That cool water keeps the eastern Pacific drier and feeds rich fishing grounds off the coast of Peru. This is the ocean's resting state, and it is called neutral. El Niño is what happens when that setup breaks down. The trade winds weaken, and sometimes they even reverse and blow the other way for a spell. Without the winds holding it in the west, the warm water sloshes back east, spreading across the middle of the ocean towards South America. The warm surface that was bunched up on one side now stretches across much of the Pacific. That is the whole event in one sentence. Warm water, normally held in the west, slides east across the equator. Everything else follows from that shift. And a great deal does follow, because the rain goes where the warm water goes. In neutral times, the heaviest tropical rain sits over the western Pacific. During El Niño, it moves east with the warm water, out over the Central Ocean. That may sound like a small relocation of clouds. It is not. The rising air over that warm water is one of the engines that drives the winds around the whole planet. Move the engine, and the winds downstream of it move too. That is how a change on the equator reaches into distant winters and monsoons. La Niña is the mirror image, and naming it here keeps the pair clear. During La Niña, the trade winds blow harder than usual. They pile the warm water even further west and pull up even more cool water in the east. The ocean leans harder into its normal state. Where El Niño tends to warm the globe for a time, La Niña tends to cool it slightly. The two take turns, with quiet neutral spells in between, on a loose cycle that runs every few years. It is not a clock. It is more like weather that plays out over seasons instead of days. The whole back and forth has a name, the El Niño Southern Oscillation. That is a mouthful, so most people shorten it. The oscillation part points to the seesaw in the air, the rise and fall of pressure across the Pacific that moves in step with the ocean's warming and cooling. Ocean and atmosphere are locked together in this. Neither leads for long without the other following. It is worth pausing on how the names came about, because they carry a small piece of history. Fishermen off the coast of South America noticed long ago that the coastal waters would sometimes turn warm around Christmas. They called that warming El Niño, a reference to the Christ child and the season. For most of history, that was the whole story, a local warming off Peru. Only much later did scientists work out that the coastal warming was one edge of a pattern spanning the entire ocean, tied to the winds and the pressure across the whole tropical Pacific. So the label on today's advisory reaches back to those fishermen and their word for a warm current at Christmas. What they saw as a local quirk turns out to be one of the largest climate patterns on Earth, and the one now settling into place across the Pacific. That is the surface story. Warm water moves east, rain follows, and the winds of the world take note. But the surface is only half of it. To see why this particular event may grow so strong, you have to look down into the water that no satellite can see and no fisherman ever touches. Most of the story so far has been about the surface, because the surface is what the satellites read and the buoys report. But the surface is only the top of a very deep pool. To understand why forecasters think this event could grow into a large one, you have to look at the water underneath, the part no one sees. Below the warm surface layer, the ocean holds a reserve of heat that has been building for a while. During the years before an El Niño, while the trade winds are still piling warm water into the western Pacific, that warm water does not just sit on top. It stacks up in depth, forming a deep pool of warmth on the western side of the ocean. It is like water held behind a wall. You cannot see how much is there by looking at the surface. You have to know how deep it goes. By the time this El Niño began to form, that deep western pool held an unusually large amount of heat. Scientists measure this as ocean heat content, which is just the total warmth stored in the upper layers of the sea, not only at the surface but hundreds of feet down. And the reading was high. In fact, the stored heat rivaled what was present before the Great El Niño of the late 1990s, the strongest event ever measured. That comparison is confirmed by the subsurface data, and it is the single biggest reason forecasters take the possibility of a top-tier event seriously. Here is why the hidden heat matters more than the surface reading alone. An El Niño feeds on that deep warm pool. When the trade winds relax, the pool is free to slide east and spread out. The more heat that was stored before the event began, the more there is to release, and the stronger the surge can be. A shallow warm layer gives you a modest El Niño. A deep, loaded one gives you the potential for a giant. Think of it as a battery. The years of trade winds charged it, packing heat into the western Pacific. Now the winds have eased, and the battery has begun to discharge, sending that warmth eastward along the equator. The charge going in was large this time. That is what has forecasters watching so closely. You can even see the discharge happening in a way. Along the equator, beneath the surface, warm water moves east in slow pulses. Instruments track these pulses as they travel, and over recent months they have been arriving on the eastern side and rising toward the surface. Each pulse that surfaces adds another push of warmth to the eastern and central Pacific. The reading in the famous box climbs a little higher with each one. That is the deep pool caching itself out at the surface, where the satellites finally catch it. None of this guarantees a record. A loaded ocean is a strong hint, not a certainty. The heat has to keep moving east, and the winds have to keep cooperating, and the atmosphere overhead has to lock in step. Any of those can stumble, but the raw ingredient, the stored heat, is present in an amount that only shows up before the largest events. That is a confirmed measurement, and it is the foundation under every forecast in this report. There is a reason this deep heat has drawn extra attention beyond the usual. The world's oceans as a whole have been running warm in recent years, warmer than the long records. So the deep pool feeding this El Niño is not starting from a cool baseline, it is starting from a warm one. The battery was not only well charged, it was sitting in an already heated room. That combination, a loaded Western Pacific on top of broadly warm seas, is part of why some models reach for the word record. Hold that image of the deep loaded pool, because it is about to move. What sets it free is not something in the water at all. It is the wind. The trade winds have held that heat in place for years, and the moment they let go is the moment El Niño truly begins. That release is the next piece of the story, and it is where a slow build-up turns into a fast change. For years, the trade winds did their steady work, pushing warm water west and holding it there. Then, over recent months, they faltered. In places along the equator, they weakened. In some stretches, they stopped, and for short spells, they even turned and blew the other way, from west to east. That reversal is small and brief when it happens, but its effect is not small at all. These bursts of reversed wind have a name. Forecasters call them westerly wind bursts, because they blow toward the west to east direction, against the normal grain. When one occurs, it gives the piled-up warm water a shove to the east. It is the nudge that lets the loaded battery start to drain. A single burst does little on its own. A series of them, one after another, can set the whole eastward surge in motion. That is roughly what unfolded. Bursts of westerly wind arrived along the equator, and each one helped ease more warm water eastward. The deep pool began its slide. The surface in the central Pacific started to warm. And here is where the pattern shows its most important trick. The thing that turns a nudge into an event. The warming feeds itself. It works like this. When the Eastern Ocean warms even a little, the temperature gap between the warm west and the cool east shrinks. That gap is what powered the trade winds in the first place, so as it shrinks, the winds weaken further. Weaker winds let still more warm water slide east, which warms the east more, which weakens the winds again. Each step makes the next step easier. A small change grows into a large one by feeding on its own output. Scientists named this loop after the researcher who first described it, and the name is less important than the idea. The idea is that El Niño is not pushed along from outside. Once it starts, it drives itself, at least for a while. That self-driving quality is why these events can grow so large, and why they are hard to stop once they gather momentum. It is also why a well-loaded ocean is dangerous in the sense of being powerful. Give the loop a big charge to work with, and it can run a long way before anything slows it. This is the answer to a question that puzzles people. Why should a temporary weakening of the wind lead to months of changed weather across the planet? Because the weakening is not really temporary once the loop takes hold. The wind and the warm water reinforce each other, locking the ocean into its warm state and keeping it there through the season. The trigger is brief. The result lasts. There is a limit to the self-feeding, and it is worth naming so the picture stays honest. The loop does not run forever. Eventually the deep warm pool empties out, the supply of heat to shove east runs low, and the ocean begins its slow return toward normal, and often overshoots into the cool phase afterward. That is why El Niño events peak and then fade rather than growing without end. This one will do the same in time, but that turning point is many months away. Right now, the loop is still building, not breaking. You can hear the caution in how forecasters talk about it. They will say the atmosphere is now responding, or that the coupling has taken hold. Those phrases mean the same plain thing. The air and the ocean are moving together now, not separately. That is the sign that an El Niño is truly locked in rather than flickering and fading, and by early summer that lock had clicked into place. The advisory was not issued on a warm reading alone. It came once the winds overhead confirmed that the ocean's warmth was steering them. So the trigger has been pulled and the loop is turning. The warm water is heading east, the winds are bending to it, and the two are pushing each other along. What began as a slow charging of the ocean over quiet years has become a fast, self-driven change playing out week by week. To see how much charge was waiting to be released, it helps to look back at the phase that came just before this one. The last few years set the stage for exactly this kind of loaded eastward surge. That handoff from the cool phase to the warm one is the next part of the story. Every El Niño has a before, and this one's before was a stretch of the opposite phase. In the years leading up to this event, the Pacific spent long spells in La Niña, the cool side of the cycle, with only short neutral breaks between. That history matters because the cool phase is exactly what sets up a strong warm one. Remember what La Niña does. It runs the trade winds harder than normal. Those stronger winds pile warm surface water deep into the western Pacific and pull up cool water in the east. So a long or repeated La Niña does not just cool the ocean for a while, it loads the western side with heat, packing that deep pool tighter and tighter. The cool phase is, in a sense, the charging phase for the warm one. The harder the winds blow during La Niña, the bigger the reserve waiting to surge back east later. That is why forecasters pay attention when an El Niño follows straight on the heels of a strong or drawn-out La Niña. The setup favours a large release. The battery went into this event well charged, because the years before it had been busy packing heat into the west. When the winds finally relaxed, there was a great deal of stored warmth ready to move. There is a useful way to picture the handoff. Think of the western Pacific as a bathtub with the drain plugged and the water piled toward one end by a steady push. La Niña is the push, holding the water high on the western side. When the push eases, the water rushes back to level out, sloshing east across the tub. A bigger pile, held longer, makes a bigger slosh when it lets go. That slosh, in the real ocean, is the warm surge that becomes El Niño. The transition itself unfolded in stages, and the stages are worth walking through because they show how a forecast becomes a fact. First, the cool phase faded, and the ocean settled into neutral, neither warm nor cool, sometime earlier in the year. Neutral is a quiet, in-between state, and it often comes right before a swing to El Niño. Forecasters noted at the time that the odds favoured the warm phase developing as the year went on. That was a forecast, and it carried the usual uncertainty. Then the readings began to climb. Through the spring, the temperature in the famous box rose from near normal into clearly positive territory. Month by month the number grew, from a slight warmth to a solid one. The atmosphere started to respond, the winds began to bend, and by early summer the forecast had become an observation. The event forecasters had expected was now measured and present. That is when the advisory was issued. You can see, in that sequence, why these events are among the few parts of the climate that can be called in advance. The ocean changes slowly. It gives warning. Months before the peak, the loaded western pool and the fading cool phase and the first eastward pulses all pointed the same way. Forecasters did not have to wait for the weather to change. They could read the ocean's setup and say, with growing confidence, what was coming. That lead time is the whole reason these updates carry weight. It also explains the tone of the current forecast. This is not a case where a warm patch appeared out of nowhere and left everyone guessing. The build-up was long and legible. A charged western Pacific coming out of the cool phase has produced strong El Niños before. The ingredients this time are on the large side of normal, which is why the possibility of a major event is on the table rather than merely imaginable. Still, the honest word is possibility, not certainty. A loaded setup raises the odds of a strong event. It does not lock one in. The atmosphere can fail to cooperate, the surge can lose steam, and a promising start can settle into something merely moderate. Forecasters have seen loaded oceans underdeliver before. The setup is a strong hint about the odds, and the odds are what the next chapter is really about. Because the charged ocean and the fading cool phase have pushed one number to the front of every forecast. It is the chance that this event crosses the line into rare, very strong territory by the time it peaks. That number, and what it would mean, comes next. Forecasters put a figure on it. and the figure is the reason this event has drawn the attention it has. They see roughly a 63% chance that, by winter, the warming in the central Pacific climbs past 2 degrees Celsius above normal. That is a little over 3.5 degrees Fahrenheit spread across that vast slab of ocean. Cross that line, and the event earns the label very strong. In everyday speech, that is a super El Niño. 63% is worth reading plainly. It is better than a coin flip, and clearly so, but it is not a sure thing. Think of it as closer to 2 chances in 3. That leaves a real 1 chance in 3 that the event stays below the top line and peaks as something merely strong or moderate. So the honest summary is this. A top-tier event is the single most likely outcome, and it is far from guaranteed. Both halves of that sentence are true, and both matter. It helps to know how rare the top tier really is, because rarity is what makes the odds notable. In the modern record, going back to the middle of the last century, only a small handful of El Niños have crossed into very strong territory. They arrive maybe once a decade, sometimes less often. So the forecast is not saying this will be a slightly worse than average year. It is saying there is a solid chance of joining a very short list of the largest events ever measured. Some models go further, and their reach is worth reporting with the caution it deserves. A number of the forecast systems push the peak beyond even the recent giants, and see the possibility of the strongest El Niño since at least the 1950s. That is a striking claim. It is also, at this stage, an outer edge of the range rather than the centre of it. Not every model shows it, and the ones that do are describing a peak still months away, in a season when the atmosphere has room to surprise. It belongs in the report because it is real. It does not belong at the centre because it is not the most likely case. There is a distinction hiding inside all these numbers, and it will matter more as the report goes on. The odds and the model peaks describe the ocean, the temperature of the water in the box. That is what the 2-degree line measures. But the ocean's temperature and the weather it produces are not the same thing. A very warm ocean usually drives strong weather effects. Usually. The link is reliable but not perfect, and the gap between the two is exactly the catch this report will come to. For now, keep the two ideas on separate shelves. There is how warm the water gets, and there is how hard the atmosphere responds. This chapter is about the first. Why does crossing the 2-degree line matter so much if it is only a temperature? Because the strength of the ocean warming tends to scale the strength of the global effects. Weak El Niños often pass with little notice, their fingerprints faint and easy to miss. Very strong ones are the events that leave a mark on the record, the ones people remember by name years later. The warmer the box in general, the louder the pattern speaks across the planet. So the 2-degree line is not just a milestone for scientists. It is a rough dividing line between an event that whispers and one that carries. It also shapes what forecasters can say about the season ahead. During a very strong event, the classic El Niño weather patterns show up more reliably and more clearly. The wet places get wetter with better odds. The dry places get drier with more confidence. In a weak event, those tilts are so slight they may not appear at all. So the higher the peak, the more forecasters can lean on the historical playbook, and the more useful their seasonal outlooks become. Strength buys clarity. Set against all this is the plain fact that the peak has not happened yet. The 63% is a forecast. The strongest since the 50s talk is a possibility at the edge, and the atmosphere between now and winter will decide which way things break. What can be said with confidence is that the setup supports a large event and that the odds favour one. What cannot be said yet is exactly how large. To understand what a strong event actually does to the air around the planet, it helps to look at the great engine El Niño reshapes. It is a loop of air that circles the tropical Pacific, and when El Niño flips it, the effects fan out to the world. There is a great circle of air that runs across the tropical Pacific, and it turns the whole ocean's weather. Picture it from the side like a loop standing on end. On the western side, over the warm water near Indonesia, air rises. It rises because warm water heats the air above it, and warm air climbs. Up high, that risen air drifts east across the ocean. On the eastern side, over the cooler water near South America, the air sinks back down, and along the surface it flows west again, closing the loop. Those surface winds flowing west are the trade winds we already met. This whole standing loop is the engine. Scientists named it after the researcher who first traced the pressure seesaw behind it, and the name is less important than the shape. What matters is that the loop connects the whole tropical Pacific into one turning system. rising air and rain in the west, sinking air and dry skies in the east, winds tying the two together along the surface. That is the neutral state, the ocean at rest. El Niño weakens this loop and can even reverse part of it. As the warm water slides east, the rising air and the heavy rain follow it out over the central Pacific. Now the air is rising in the middle of the ocean instead of only in the far west. The neat loop gets muddled. The trade winds, which were the loop's surface leg, slacken because the temperature gap driving them has shrunk. In a strong event, the whole circulation sags and shifts east, its western engine stalling as its centre of action moves toward the open ocean. This sounds like an abstraction, a diagram in a textbook. It is not. The rising branch of that loop, the place where air climbs and rain pours, is one of the main pacemakers for winds across the entire globe. When it sits in the far west, the world's winds arrange themselves one way. When El Niño drags it into the central Pacific, they rearrange. Jet streams, the fast rivers of high wind that steer storms across continents, shift their paths in response. That is the mechanism, in plain terms, by which a change on the equator reaches a winter in North America. Follow one thread to see it work. When the rising air and rain move east, the pattern of high winds over the North Pacific changes, and the main storm-steering jet stream tends to extend and dip south. That southward dip guides storms across the southern United States that in other years would have travelled a different route. So a family in the American South may see a wetter, stormier winter, and the root of it is a patch of warm water and rising air thousands of miles away on the equator. The loop moved, the jet stream bent, and the storms followed the bend. The same shift explains why El Niño's effects are so scattered and so specific. It does not simply make the world warmer or wetter everywhere. It relocates the rising and sinking branches of the tropical circulation, and wherever those branches land, the weather changes to match. Under the new rising branch, rain increases. Under the new sinking branch, drought deepens. That is why one El Niño can flood one country and parch its neighbour. The loop has simply set its wet end over one and its dry end over the other. There is a reason forecasters watch the air and not only the water. The ocean can warm, but until the loop responds, the global effects stay muted. The advisory this summer came only after the atmosphere began to move with the ocean, the rising air sliding east as the water warmed. That coupling, the air and sea turning together, is what makes an El Niño a global event rather than a local warm spell. A warm ocean with an unresponsive atmosphere is a quiet El Niño. A warm ocean that bends the Great Loop is a loud one. That distinction is going to return, because it sits at the heart of this event's biggest question. The water is clearly warm, the loop is responding, but how fully it responds, how far the Great Circle bends, will decide whether this event hits with the force its ocean temperature suggests. Hold that thought. For now, the picture is complete enough to move forward. A giant loop of air spans the Pacific, El Niño shoves its engine east, and the world's winds rearrange around the shove. To see what that rearrangement can do at full strength, there is no better guide than the largest El Niño ever measured, the one this event keeps getting compared to. When forecasters reach for a comparison this year, they reach for one event above all others. It is the El Niño of the late 1990s, the strongest ever measured, the yardstick against which every large event since has been held. The reason it comes up so often now is not drama. It is that the deep ocean heat feeding this event rivals what was present before that one, so its story is worth telling plainly, both for what it did and for what it teaches. That event grew into a giant, pushing the warming in the central Pacific well past the very strong line, and as it peaked, the global effects arrived on cue, one region at a time. The great loop of tropical air had shifted hard, and the world's weather rearranged around it in ways that left a lasting record. The list of what followed is sobering, and it is best given plainly, without heightening. Torrential rains fell across parts of South America, and Peru saw serious flooding. Heavy rains struck East Africa as well. Those East African rains, by leaving standing water across the land, helped touch off an outbreak of a mosquito-borne illness in the region, a reminder that weather and health are not separate stories. On the other side of the pattern, droughts settled over Southeast Asia, and dry conditions helped fires spread through the region's forests, filling the air with smoke for weeks. In California, powerful storms brought flooding and landslides, and out in the ocean itself the heat ran so high that coral reefs bleached across a large share of the world's reef systems, something like 1 in 6 of them. Read that list again and notice its shape. Floods in one place, drought and fire in another, disease riding in on the rain, damage on land and damage at sea. That scatter is the signature of a strong El Niño. It is the great loop setting its wet end and its dry end over different parts of the world at once, and every region living out the piece of the pattern it was handed. There is a number attached to the human cost, and it is worth stating carefully because it is easy to inflate. Researchers who studied the economic toll estimated that the event of the late 1990s was linked to global income losses reaching into the trillions of dollars, with one careful study putting the figure near 5.7 trillion. That is not damage from a single storm on a single day. It is the sum of many effects across many countries over the years that followed, from lost harvests to strained economies. A strong El Niño, the research suggests, leaves a mark on the world's finances that lingers well after the warm water is gone. That lingering is the part people tend to forget. An El Niño is not a weekend event. Its peak lasts a season, but its consequences stretch on. A failed harvest raises food prices for a year. A flood rebuilds slowly. A drought empties reservoirs that take far longer than one wet season to fill. The event of the late 90s is remembered as a single-named giant, but its costs were paid out over a long tail of time. That long tail is one of the truest lessons it offers the present. Now the necessary caution, because a comparison can mislead as easily as it can guide. No two El Niños are alike. The event forming now shares that giant's loaded ocean, but it will write its own story. It may land its floods and droughts in different places. It may peak higher or fall short. The late 90s event is the closest analogue available, not a script. Using it as a guide means learning the shape of what a strong event can do, not predicting that the same countries will see the same disasters on the same schedule. There is also a hopeful difference between then and now, and honesty requires naming it alongside the warnings. Forecasting has improved. The lead time is longer, the models are sharper, and the world has lived through more of these events and learned from them. The event of the late 90s struck a world less prepared to see it coming. This one arrives with months of warning already given, which is time that can be used. Preparation does not stop an El Niño. It softens what it costs. The late 90s giant is the loudest example, but it is not the only one. A small club of very strong events sits alongside it in the record, and comparing them together reveals what these giants share. That comparison is the next step. The late 1990s event stands tallest, but it does not stand alone. Two other El Niños in the modern record crossed into very strong territory, and setting the three side by side shows what the giants have in common. One came in the early 1980s, another came in the middle of the 2010s, about a decade ago. Together with the late 90s event, they make up the short list of super El Niños in the reliable record. 3 events, spread across roughly 40 years. That spacing is the first lesson. These are rare. Look at how each one grew, and a shared shape appears. Each began quietly in the spring, a warm anomaly building in the central Pacific with little fanfare. Each strengthened through the summer and fall, and each peaked in the heart of winter when it crossed the very strong line and did its loudest work. The rhythm was the same every time. Slow start, steady climb, winter peak, then a fade into the following year. The event forming now is following that same opening rhythm, which is part of why the comparison feels apt. The early 80s event, the first of the 3 in the modern record, arrived at a time when these patterns were far less understood. It caught much of the world off guard. Its effects rippled across continents, and like the later giants, it was linked to large global losses, with estimates of the economic toll running into the trillions in the studies done since. Coming when it did, before the forecasting tools that later became routine, it became a hard lesson in how far the reach of a Pacific warming could extend. Much of what scientists learned about El Niño in the following years was learned by studying what that event had done. The event of about a decade ago, in the middle of the 2010s, is the one many people alive today actually remember. It too grew into a giant, and it too left its marks, from drought and fire in some regions to flooding in others. But it carried an extra feature worth naming, because it points toward this event's central question. It arrived on top of an already warming world. The background temperature of the planet had crept up, so when that El Niño added its own warmth, the total pushed global temperatures to new highs for the time. The event did not act alone, it stacked on a rising baseline, and the sum set records. That stacking is the thread that ties the old giants to the present one, and it is the reason the past matters here beyond mere history. Each of these events released a burst of ocean heat into the atmosphere. Each nudged the whole planet's temperature upward for a time, and the more recent the event, the warmer the world it landed on, so the higher the total climbed. The giants are not just weather stories. They are steps in a longer climb, each one briefly lifting the global temperature to a new mark before settling back. There is a difference among the three that keeps the comparison honest. Each landed its floods and droughts in somewhat different places, and each varied in exactly which effects were strongest. One brought its heaviest blows to one set of regions, another to a different set. This is the reminder that a giant's strength tells you the scale of the disruption, but not its precise address. Knowing an event will be very strong tells you to expect large effects somewhere. It does not tell you which valley floods and which forest burns. That detail only comes as the season unfolds. Put the club together, and the takeaways are clear and few. Very strong El Niños are rare, arriving perhaps once a decade. They share a life cycle, building through the year to a winter peak. They scatter floods and droughts across the globe in a recognizable pattern, though never at the exact same addresses, and each recent one has stacked its heat on a warmer world, lifting global temperature to a new high for its time before fading. That last point is the one that leads somewhere unexpected, and it deserves a chapter of its own to handle with care. Because the same warming baseline that made the recent giants so hot also complicates how we read this new event's strength. The raw ocean number is high, but a high number today may not mean quite what it meant when the older giants were measured. That wrinkle, the catch that hardly anyone outside the field is talking about, is where the report turns next. Here is the catch, and it is the quiet twist at the centre of this whole event. The ocean number is high, higher than almost any on record for this stage of the season, but that number may not hit as hard as it reads. The reason is simple, and it changes how the rest of the story should be understood. Start with the problem in plain form. The index that measures El Niño compares the temperature in that famous box of ocean against a long-term average. But the whole ocean has warmed over the past several decades, so the water in the box now starts from a warmer baseline than it did when the older giants were measured. Some of the high reading today is the El Niño itself, and some of it is just the general warming of the seas, the rising floor beneath everything. The thermometer cannot tell the two apart, it only reports the total. That means a reading of, say, 2 degrees above the old average does not describe the same El Niño it would have described 50 years ago. Back then, most of that 2 degrees was the pattern itself. Today, a share of it is the warmer world underneath. The label very strong is based on the raw number, so the raw number can push an event into the top tier partly on the strength of the background warming, not the pattern alone. The event looks bigger on the gauge than the pattern by itself may be. Forecasters saw this problem coming and built a fix. They now watch a second, adjusted index alongside the traditional one. The adjustment is straightforward in idea. It subtracts out the general warming of the wider tropical oceans, leaving behind just the part that is truly the El Niño pattern. When you strip away the rising floor, you get a cleaner read on how strong the pattern itself really is. That adjusted view is the one that better matches the weather these events actually produce. And here is where it gets interesting for this year. On the raw index, this event looks like a possible record, rivaling the largest ever measured. On the adjusted index, which removes the background warming, the same event looks more moderate. The two gauges disagree, and the gap between them is the catch. The ocean may set a record on the old thermometer while the pattern that drives global weather runs only middling. One event, two very different readings, depending on which ruler you use. Why does this matter beyond a debate over measurement? Because the adjusted index tends to line up better with what the atmosphere actually does. There is a recent case that shows it clearly. A couple of years ago, an El Niño looked, on the traditional index, like it should bring a wet, active pattern to the southern United States. The raw number promised a lot, but the atmosphere responded weakly, and the expected rains largely did not arrive. The adjusted index had shown a more muted event all along, and the muted version is what the weather delivered. The lesson stuck. When the two gauges disagree, The adjusted one has often been the better guide to real effects. So the honest forecast for this event carries a split screen. The oceanic side may well be historic, and the raw number may cross into record territory by winter. That much the stored heat supports. But the atmospheric side, the actual weather-driving strength of the pattern, may come in a notch or two below what the raw number advertises. A record on paper, in other words, could still produce something less than record-breaking on the ground. This is not a reason to relax, and it should not be read as one. Even a moderate El Niño sitting on top of an already hot planet can push global temperatures to new highs and tilt the odds toward floods and droughts around the world. The catch does not cancel the event. It refines the expectation. It says the ocean's raw strength may overstate how hard the weather affects land, and it warns against reading the record-breaking headlines about water temperature as a guarantee of record-breaking weather. That refinement is what makes this event genuinely worth close attention rather than easy alarm. The most likely story is a very warm ocean whose atmospheric punch is uncertain, sitting on a baseline that is itself running hot, which raises the one outcome that is far more certain than any flood or drought, the one that the warming baseline makes almost unavoidable. That outcome is heat, and it is where the report turns next. Set aside for a moment the question of floods and droughts and exactly where they land. Those depend on how the atmosphere responds, which is the uncertain part. There is another outcome that is far more certain, and it is the one that gives this report its title. It is heat. Not the heat of a single hot afternoon, but a steady lift in the temperature of the whole planet, and it is already underway. Here is why heat is the near-sure bet when so much else is uncertain. An El Niño works by moving a vast quantity of warm water up to the ocean surface and spreading it across the Pacific. Once that heat is at the surface, it passes into the air. A warmer ocean surface warms the atmosphere above it, and because the Pacific is so large, the effect shows up in the global average temperature. This is not a subtle statistical tilt. During strong El Niño years, the planet reliably runs hot. It is one of the most dependable effects in all of climate science. Now add the piece that makes this event different from the giants of the past. This El Niño is not warming a cool world. It is warming a world that was already running at or near record heat before the event began. The oceans as a whole have been unusually warm in recent years, warmer than the long records. So the extra warmth from El Niño is not the first heat of the year. It is heat piled on top of heat. The event is a warm surge added to an already warm baseline. Stack those two together and the arithmetic points one way. A reliably warming effect, added to a record warm starting point, tends to produce a record warm result. That is why forecasters and climate scientists say, with unusual confidence for a forecast, that this year is very likely to end up among the hottest ever measured, and quite possibly the hottest. The uncertainty is not really about whether the world warms, it is about by how much, and whether the final tally sets a new mark or merely comes close. Notice how this outcome differs from the ones people usually brace for. When most people think about El Niño, they picture a specific disaster, a flood in one place, a drought in another, a storm with a name. Those are the visible dramas, and they may or may not arrive at any given address. But the heat is different. It does not need to pick a target. It lifts the whole average, everywhere, at once. It is the quietest outcome and the most certain, which is exactly why it is the one people are least ready for. A flood makes the news. A slow global rise in the baseline does not announce itself the same way, even though it touches more of the world. The heat also does not stay politely inside the ocean's box. Broadly warmer conditions this summer and fall are the first sign, showing up as unusual warmth across large parts of the globe rather than as any single record afternoon. The world's authoritative forecasters have already flagged a near-universal tilt toward above-normal temperatures over land in the seasons ahead. That is the heat arriving, not as a heat wave in one city, but as a gentle upward push almost everywhere. Some regions will feel it as ordinary warmth. Some, where it combines with drought, will feel it as a real stress. There is a human edge to this that deserves plain, calm mention. Sustained heat is not merely uncomfortable. Where it deepens drought, it strains water supplies and crops. Where it lingers, it raises the risk of heat stress for people who work outdoors or lack cooling. These effects are manageable with ordinary care, staying hydrated, checking on vulnerable neighbours, respecting the warnings that local officials issue. The point is not alarm. It is that the heat, unlike a distant flood, is an outcome that reaches nearly everyone in some form, and the heat has a longer reach in time than the event that triggers it, which is the part almost no one accounts for. The warmth an El Niño releases does not vanish when the ocean cools. It works its way through the climate system for months afterward. So the hottest stretch often comes not at the event's peak but in the year that follows, as the released heat spreads through the atmosphere. That delayed, drawn-out warming is the true shape of this outcome, and it is where the report picks up next. The warmth an El Niño releases does not settle up its accounts when the ocean cools. It lingers, and it moves through the climate on a delay. That delay is why the hottest stretch of a strong event so often falls not at the peak itself, but in the months and the year that follow. Scientists have a plain phrase for the pattern it produces. They call it a stair-step, and it is worth walking through because it changes how to read what is coming. Picture the planet's temperature not as a smooth ramp but as a staircase. For a stretch, the temperature holds roughly level, wobbling year to year without much net gain. Then a strong El Niño arrives, releases its burst of ocean heat into the air, and the temperature jumps up a step. When the El Niño fades, the temperature does not fall all the way back to where it started. It settles onto the new step, a little higher than before. Then it holds there until the next big event lifts it again. Up a step, hold, up another step. That is the stair step, and the recent giants have each been one of the risers. This event looks set to be the next riser. The heat it is pouring into the atmosphere now will keep working through the system as the months pass. So even as the ocean pattern peaks this winter and begins to weaken afterward, the atmospheric warmth is likely to keep building into the following year. The event fades in the water while its heat is still climbing in the air. That lag is the reason forecasters expect the strongest global warmth to show up later, spilling past the El Niño that caused it. There is a real-world shape to how that spillover tends to arrive. The first sign is broad, gentle warmth over the tropics and subtropics, the parts of the world nearest the warm ocean, showing up through this summer and fall. Then, as the released heat spreads toward the middle latitudes, it tends to show up there in the year that follows, often as sharper heat events in places farther from the equator. The warmth migrates outward and forward in time, from the tropics now to the wider world later. It is a slow-motion release, not a single flash. Why does this matter for anyone planning ahead? Because it means the story does not end when the El Niño does. People naturally watch for the peak and assume the danger passes once the ocean cools. But the heat outcome runs on its own schedule. The year after a strong El Niño can be as warm as the event year, sometimes warmer, precisely because of this lag. Anyone bracing only for the winter peak is bracing for the wrong window. The heat's main act may come later. It also puts recent history in a clearer light. Each recent giant lifted the world to a new temperature high, and the record often fell in the event year, or the one right after. Then the world held near that new level until the next riser came along. The long climb of global temperature has not been a smooth line. It has been this staircase, with the big El Niños providing many of the steps up, and the quiet years providing the flat stretches in between. The honest caution belongs here too, and it is the same one that runs through this whole report. How high this particular step rises depends partly on how strongly the atmosphere responds, which is the uncertain part. A more muted atmospheric response, of the kind the adjusted index hints at, would mean a smaller step. A full-throated response would mean a larger one, so the stair step is coming. Its exact height is not yet set. What can be said is that the direction is up, and that the rise will likely outlast the event that drives it. None of this requires a sense of dread. It requires a sense of timing. The certain outcome is a warmer world, arriving on a delay, cresting after the ocean pattern has already begun to fade. That is the shape of the heat, and it is the backbone of everything this event will mean for the year ahead. Heat is the outcome that reaches nearly everyone, but an El Niño does more than warm the average. It moves the rain, taking it from some places and dumping it on others. The taking comes first in this account because for a large share of the world, a strong El Niño means the rain simply goes missing. Where it vanishes, and why, is the next piece of the map. For a large stretch of the world, a strong El Niño means one thing above all. The rain that usually comes does not. To see why, return to the great loop of tropical air. When El Niño drags the rising, rain-making branch east toward the central Pacific, the places that used to sit under that rising branch are left under sinking, drying air instead. The clouds that fed them have moved. Drought follows. The clearest example sits on the western side of the Pacific, over Indonesia and the surrounding maritime region. In normal times, this is one of the rainiest places on Earth, sitting squarely under the loop's rising branch. During El Niño, that branch shifts away to the east, and the region dries out. Rainfall drops, and the risk of drought and wildfire climbs. The same warm water that brings rain to the Central Ocean takes it away from the islands to the west. It is the pattern's give and take made visible in a single region. Australia often shares that fate, and for the same reason. El Niño years tend to bring drier, hotter conditions across much of the continent, raising the danger of drought and bushfire. The land bakes, reservoirs draw down, and the fire season arrives with more fuel and more heat behind it. For a country already familiar with drought, a strong El Niño tilts an already hard situation harder. The tilt is a forecast, not a certainty, but it is one of the more reliable tilts in the whole pattern. The reach extends well beyond the Pacific Rim. Across parts of the Amazon in South America, strong El Niños are linked to reduced rainfall, which stresses the forest and raises fire risk in a place that is normally wet. In southern Africa, the pattern can bring drought during the region's summer, straining crops and water supplies. Even the Caribbean often sees drier conditions. Each of these regions sits at a spot where El Niño's rearranged circulation favours sinking, drying air, and each pays for it in lost rain. Then there is the monsoon, which deserves its own mention because so many people depend on it. Across South Asia, and India in particular, the summer monsoon delivers the rain that a huge share of farming relies on. El Niño tends to weaken that monsoon, nudging it toward less rain than normal. Forecasters this year have leaned toward a below-average monsoon across parts of the region, and there is an added concern worth naming plainly. When an El Niño follows soon after the cool phase, as this one does, the monsoon shortfall can be especially pronounced. A weak monsoon is not a small matter. It can mean thinner harvests and higher food prices for a very large number of people. Notice the human shape of this drought side. These are not empty deserts that dry a little more. They are farmed lands, forested lands, inhabited lands. When the rain goes missing across Indonesia or India or southern Africa, the cost is measured in crops that do not grow, reservoirs that do not fill, and fires that find more to burn. The heat outcome from earlier compounds it, because hotter air dries the soil faster and deepens whatever drought the missing rain begins. Drought and heat work together, each making the other worse. The honest caution holds here as firmly as anywhere. These are tilts in the odds, not guarantees for any single place. A weakened monsoon is a lean toward less rain, not a promise of failure. A drought-favouring pattern raises the chance of dry conditions without dictating them, and the strength of these tilts depends on how strongly the atmosphere responds, the same uncertainty that runs through the whole event. A more muted pattern would soften these drought risks, a stronger one would sharpen them. The direction is set, the severity is not. For the people in these regions, the standard guidance is the calm and ordinary kind. Where drought is favoured, water managers plan for less, and farmers weigh their planting against a drier outlook. Where fire risk climbs, communities prepare early. None of it is dramatic. All of it is the quiet work of using the months of warning that a forecast like this one provides. That is the dry half of the pattern, the rain taken away. But the loop that steals rain from one side of the world hands it to the other. Somewhere the clouds have moved to, the rain is falling harder than usual. Where that rain piles up is the other half of the map. The same shift that steals rain from one side of the world delivers it to another. Wherever El Niño moves the rising branch of tropical air, and wherever the bent jet streams steer the storms, the rain piles up. For those regions, a strong El Niño means the opposite problem from drought. It means too much water, arriving too fast. The clearest example for a large audience is the southern tier of the United States. Recall the mechanism from earlier. When El Niño shifts the tropical rain east, the storm-steering jet stream over the North Pacific tends to extend and dip south. That extended jet acts like a conveyor belt, carrying one storm after another across the southern states through the winter. So a band running from the southwest across the south tends to turn wetter and cooler than usual during a strong El Niño. The storms that skipped these areas in drier years now find a path straight through them. For the drier parts of that band, especially the southwest, a wet El Niño winter can be a relief, easing drought and refilling parched ground. But wet is not the same as gentle. When storms line up and roll through in series, the rain can come faster than the land can absorb, and relief tips into flooding. The same conveyor that eases a drought can, in a strong event, overwhelm the ground it is watering. Which of those two faces the season shows depends on how hard the pattern runs, and that is not yet known. East Africa sits on the wet side of the pattern too, and its story carries an extra weight. During the season that runs from around October into the new year, the region nearer the Horn of Africa can see heavy flooding rains during a strong El Niño. That is a life and death matter in places, both for the immediate danger of the water and for what standing water can bring afterward. The great event of the late 90s left exactly this mark on the region, with flooding rains followed by an outbreak of disease. It is a clear case of the same pattern that parches southern Africa, drowning the land a little to the northeast. South America shows the split within a single continent. While parts of the Amazon dry out, a portion of the southeast, across parts of the region's lower latitudes, tends to see heavier rainfall during El Niño. One country can hold both faces of the pattern at once, drought in one region and flood in another, because the loop has set its dry branch over one part and steered extra storms into another. It is the whole global pattern in miniature, playing out inside one landmass. The reason the flood side deserves as much attention as the drought side is that it arrives faster and hits harder in the moment. Drought is slow. It creeps in over weeks and reveals itself in falling reservoirs. Flooding is sudden. A single strong storm in a series can turn a river or a hillside dangerous within hours. So while drought does the deeper long-term damage in many places, flooding often does the sharpest immediate harm, and it is the side that calls for the most direct, standard safety care when the warnings come. That care is the ordinary, well-worn kind, and it is worth stating simply. In regions where a wet, stormy pattern is favoured, the guidance is to heed local flood warnings, avoid driving through water on roads, and know the ground that tends to flood or slide. None of that is unusual advice. It is the standard playbook for a wet season, applied a little more carefully in a year when the odds of heavy rain run higher than normal. And the same honesty applies as on the dry side. These are tilts, not certainties, and their strength rides on how fully the atmosphere responds. A muted pattern would mean lighter, less reliable rains. A strong one would mean the conveyor runs hard. The regions on the wet side of the map are known. How much falls on them is the open question. One place on that wet side draws special attention every strong El Niño, because it holds so many people and such a history of dramatic winters. That place is California, and its winter question is worth taking on its own. California draws special attention in every strong El Niño, and this year is no exception. The reason is partly its history and partly its stakes. A large population lives there, much of it below hills and along rivers that can turn dangerous in a wet winter, and the state has lived through El Niño winters that delivered exactly that, storms stacked one after another, with flooding and landslides in their wake. So when a strong event forms, the question arrives quickly. What kind of winter is coming to California? The honest answer starts with the setup, which does lean wet. During a strong El Niño, that extended southward dipping jet stream can aim its parade of storms squarely at the state. Forecasters looking at the seasonal outlooks for the coming winter have noted that the ingredients on the table resemble the recipe for a wet California winter with raised flood risk. The pattern the models are painting looks, in its broad strokes, like the kind that has soaked the state before. That is a real signal, and it is why California is on the watch list. But the honest answer does not stop there, because California is also one of the harder places to forecast in these events. The state sits at a kind of hinge in the pattern. Strong El Niños have brought it drenching winters, but not every time, and the relationship is looser than the clean conveyor belt farther south. Some strong events delivered the expected storms, others underperformed, leaving the state drier than the setup suggested. So the lean toward a wet winter is real, but the confidence behind it is lower here than in regions where the pattern is more dependable. There is a piece of good news folded into the risk, and it belongs in any honest account. Much of the American West has been gripped by a long, severe drought, with reservoirs and river systems drawn down over years. A genuinely wet winter, for all its flood danger, would also be a chance to recharge some of that lost water. So the same storms that raise the flood risk could, if they arrive in the right measure, ease a drought that has been building for a long time. The trouble is that too much of a good thing turns into a hazard. A moderate wet winter refills reservoirs, an extreme one floods towns. The line between the two is thin, and which side of it a season lands on cannot be known in advance. There is a further wrinkle particular to California worth naming, because it ties back to the heat outcome. Before the wet winter can even begin, the state faces a warm, dry stretch through the late summer and into fall, the tail end of its normal fire season. If heavy rain holds off until deep in the fall, the dry months beforehand can leave the landscape primed to burn. So California's El Niño story this year may come in two acts. A fire risk act in the warm months, followed by a flood risk act if and when the storms finally arrive. The heat and the rain, in sequence, on the same ground. All of this makes California a place to watch rather than a place to predict with confidence. The setup favours a wet, possibly stormy winter. The state's loose relationship with the pattern means that setup could underdeliver. The drought raises the stakes on both sides, since the state needs the water but cannot easily absorb a deluge. And the timing of the first big storms will decide how the fire season ends. Every one of those threads is live and none is settled. The guidance, as everywhere, is the calm and standard kind. In a year when a wet winter is favoured, the sensible steps are the familiar ones. Know whether your ground floods or slides. Keep an eye on the forecasts as the season turns, and treat the warnings seriously when they come. There is no call for worry now in the warm early months. There is a call to stay aware, because the season that could test the state is still forming. California is one region on a much larger map, and its winter is one thread in a pattern that redraws the whole of North America's cold season. To see the rest of that map, it helps to step back and look at the continent as a whole. Step back from any single state, and the whole of North America takes on a recognizable shape during a strong El Niño winter. The pattern is not random. It follows the bent jet stream, and once you know how the jet bends, you can read the map region by region. This is the closest thing El Niño offers to a seasonal playbook, and in a strong event the playbook tends to hold. The engine of the whole map is that southward shifted storm track. In a normal winter, the main Pacific jet stream and its storms tend to cross into the continent farther north. During a strong El Niño, the jet extends across the Pacific and dips south as it reaches North America. That single shift sets nearly everything else. Storms ride the lower track, so the south gets the weather the north usually would, and the north is left drier and milder in its place. Start with the southern tier, since it feels the clearest effect. From the southwest across the southern plains and into the southeast, the season tends to run wetter and cooler than normal. The lower storm track carries system after system across these states, bringing rain and, at times, the chance of snow where the air is cold enough. For a region that has struggled with drought, this is the hopeful side of the pattern, though as noted, a strong enough parade of storms can flood as easily as it can relieve. Now the northern tier, which sees the mirror image. Across the northern states and into western Canada and Alaska, a strong El Niño winter tends to run warmer than usual. With the main storm track shoved south, these regions often miss the parade and milder air settles in. This does not rule out cold snaps. A warmer than average winter still has its cold days and its storms, but the overall lean is toward warmth in the north, a gentler season than normal for much of the region. Between those two bands lie the areas that tend to dry out. The southward shift in the storm track tends to leave parts of the interior, including the Ohio and Tennessee valleys, and stretches of the Pacific Northwest, drier than usual. The storms that would have crossed these areas are riding either south or a different path entirely, and the skies above are quieter for it. So the map has three broad zones: wet and cool across the south, warm across the north, and drier through parts of the middle and the northwest. It is worth saying plainly why this playbook is more trustworthy in a strong event than a weak one. The stronger the ocean warming, and the stronger the atmospheric response, the more firmly the jet stream locks into its shifted position, and the more reliably these regional tilts appear. In a weak El Niño, the shift is faint and the map blurs. In a strong one, the pattern stamps itself more clearly on the season. That is another reason the strength of this event matters so much. Strength is what turns a vague lean into a dependable forecast. And here the central caution of this whole report returns one more time, because it shapes the map directly. Every tilt just described rests on the atmosphere responding to the warm ocean. If the response comes in more muted than the raw ocean number suggests, of the kind the adjusted index has warned about, then the map blurs even in the presence of a record-warm Pacific. The regions are drawn correctly. How boldly they are drawn depends on how hard the atmosphere leans into the pattern. That is the open question that sits beneath the whole seasonal outlook. Forecasters put it well when they remind people that every El Niño is unique, each one leaving its own imprint. The playbook describes the tendency, the average of past strong events. Any single winter can depart from it in ways large or small. The map is a guide to the odds, not a schedule of certainties, and the wise way to read it is as a tilt in the deck rather than a dealt hand. One region on that map carries a special burden this year, because it has been dry for so long that a single wet winter cannot save it. The story of that lingering drought, and why one good season will not end it, is the next piece to understand. One part of that winter map carries a burden the rest do not, and it is worth its own chapter because it corrects a hopeful assumption. Across the American Southwest and the Southern Plains, a drought has been building for years, not months. Reservoirs sit low, rivers run thin, the groundwater beneath has been drawn down, and when people hear that a wet El Niño winter may be coming, the natural hope is that it ends the drought. The honest answer is that one wet winter by itself almost certainly cannot. The reason is a matter of scale and time. This drought has been deepening for close to 6 years in parts of the region. Over that stretch, the deficits have stacked up. Reservoirs that took years to draw down cannot be refilled in a single season. Aquifers that were slowly emptied recharge even more slowly, over years or decades, not weeks. Streamflow depends on more than one winter's rain, so even a genuinely wet El Niño winter would make a dent, not a cure. It would ease the surface of the problem while the deep deficits remained. There is a specific reason the deep deficits are so stubborn in this region, and it comes down to snow. Many of the large reservoirs in the southern plains and the interior west depend on winter snowpack in the mountains upstream. The snow builds up through the cold months, then melts in spring and runs down the rivers to fill the reservoirs. But the past winter left a poor snowpack in key headwaters, and a thin snowpack means a thin spring runoff, no matter how much rain falls later in the lowlands. Rain helps the soil and the short-term picture. It is snowmelt that refills the big reservoirs, and the snow account was already running low. El Niño's relationship with that mountain snow is loose, which adds to the uncertainty. In some past strong events, the pattern helped build a healthy snowpack in parts of the region. In others, it did little. The connection between El Niño and snowpack in these headwaters is real but weak, so even a strong event offers no promise of the deep mountain snow the reservoirs most need. The winter could be wet in the lowlands and still leave the crucial high country snow short. There is even a version of this where help brings its own harm. For a wet winter to truly bite into a drought this deep, it would have to be exceptionally wet, well beyond the normal, and a winter that wet risks flooding. So the region sits in an uncomfortable spot. A normal wet El Niño winter eases the drought without ending it. The kind of extraordinary winter it would take to actually end the drought would likely bring flooding along with it. There is no gentle path from a 6-year drought back to full reservoirs in a single season. Either the relief is partial, or it comes with a flood risk of its own. History backs this up in a plain way. El Niño winters have acted as drought breakers for the southern United States before, in several past strong events that delivered soaking, sustained rain. But there are also strong El Niño years that did not break the drought, where the expected rains underdelivered or fell in the wrong form, so even the hopeful precedent is mixed. Sometimes the pattern rescues the region, sometimes it does not. Counting on rescue is a gamble, not a plan. What this means in practice is a matter of managing expectations honestly. A wet winter, if it comes, is good news for the region and should be welcomed. It can refill some smaller reservoirs, green the range, and ease the immediate stress. But water managers know better than to treat one season as the end of a multi-year drought. The deep recovery, if it comes at all, will take a run of good years, not one. Planning for the region rests on that longer horizon, not on a single hoped-for winter. The lesson generalizes past this one region. A strong El Niño is powerful, But it is not a reset button. It nudges the odds for a season. It does not undo years of accumulated deficit in a stroke. Holding that in mind guards against both false hope and false despair, and it keeps the focus where it belongs, on the long, patient work of managing water through a variable climate. The drought map covers the land. But El Niño reshapes the seasons at sea as well, and nowhere more consequentially than in the story of hurricanes. The pattern quiets one ocean storm season while stirring another's, and that trade-off is the next piece. El Niño reaches the hurricane seasons too, and it does something that sounds almost contradictory at first. It tends to quiet the storms in one ocean while stirring them up in another, understanding that trade-off matters because it shapes the risk for very different parts of the world at the same time. Start with the Atlantic, where the news runs, on balance, in a reassuring direction. During El Niño, the pattern tends to strengthen the high-level winds that blow across the Atlantic where hurricanes form. Those winds create what forecasters call shear, which is simply a difference in wind speed or direction between low and high altitudes. Shear is hard on hurricanes. A developing storm needs a tall, stacked column of calm rotation to grow, and strong shear tears that column apart before it can organize. So more shear generally means fewer and weaker Atlantic hurricanes. For this reason, forecasters have leaned toward a below-normal Atlantic hurricane season this year. That is genuinely good news for the many coastlines around the Atlantic basin, but it carries a caution that must be stated clearly, because the reassurance can be misread. A quieter season is not an empty one. Fewer storms does not mean no storms. The warm ocean waters that fuel hurricanes are still there, and a single storm that does manage to form and reach land can still be devastating. History is full of quiet seasons that produced one catastrophic hurricane. So the correct way to hold this forecast is as lower odds of an active season, never as permission to lower one's guard. It takes only one storm at the wrong place to make any season a disaster for the people it hits. Now cross to the other side, where the trade runs the opposite way. The same El Niño that suppresses the Atlantic tends to enhance storm activity in the central and eastern Pacific. The warm water spreading across that ocean, and the changed wind pattern above it, make conditions friendlier for storms to form there. So while the Atlantic quiets, the eastern and central Pacific can turn busier than usual. The pattern does not reduce the total storminess of the world so much as move it from one basin to another. That shift carries real consequences for specific places. A more active eastern Pacific raises the storm risk for parts of Mexico's Pacific coast, and, at times, for Hawaii, depending on where individual storms track. There is also a knock-on effect worth naming. Storms that form in the eastern Pacific can, as they weaken over land or nearby waters, feed surges of moisture into the southwestern United States. So even for people far from the coast, the busier Pacific season can matter, arriving not as a landfalling hurricane but as a plume of tropical moisture that fuels heavy rain inland. The through line in all of this is that El Niño does not simply turn hurricanes up or down, it relocates the risk. It shifts the hazard from the Atlantic toward the Pacific, easing the danger for one set of coastlines while raising it for another. Reading the season correctly means holding both halves at once. A likely quieter Atlantic and a potentially busier eastern Pacific are two faces of the same pattern, and both deserve attention from the regions they affect. The strength of the event shapes how firmly these tilts hold, as it does everywhere. A stronger El Niño generally means more Atlantic shear and a more suppressed season there, along with a more enhanced Pacific. A more muted event would soften both effects. So the same uncertainty about atmospheric strength that runs through the rest of this report touches the hurricane outlook too. The direction of the trade-off is dependable. Its size rides on how strongly the pattern locks in. The guidance for anyone in a hurricane-prone region is the plain, unchanging kind. A below-normal forecast for the Atlantic is a reason for cautious relief, not for skipping the ordinary preparations. Keep the usual season plan ready, because the one storm that does form is the one that matters to you. And in the eastern Pacific's reach, from Mexico's coast to Hawaii, to the desert southwest that catches its moisture, the busier outlook is a reason to stay a little more alert than an average year would call for. The storms are the ocean's loudest response to El Niño, but the warm water does quieter damage too, damage that begins in the ocean itself, among the reefs and the creatures that live in the heat the pattern brings. That underwater toll is the next thread. Before El Niño's heat reaches a single farm or city, it has already gone to work on the ocean itself. The warm water that the pattern spreads across the Pacific is not just a number on a gauge. It is a living hazard for the creatures that depend on cool, stable seas. And the first to feel it, every strong El Niño, are the coral reefs. Coral is more delicate than it looks. The bright, rocky structures that build reefs are made by tiny animals that live in partnership with even tinier algae inside them. Those algae give the coral both its colour and much of its food. But the partnership only works within a narrow temperature range. When the water grows too warm for too long, the coral expels the algae, turning bone white in the process. That is coral bleaching. A bleached coral is not yet dead, but it is starving and stressed, and if the heat lasts, it dies. During the Great El Niño of the late 90s, the ocean ran so warm that bleaching struck something like 1 in 6 of the world's reefs. A strong event this year raises the risk of another widespread bleaching. The damage does not stop at the reefs. The broad warming of the ocean surface during a strong El Niño amounts to a marine heat wave, a stretch of unusually hot water covering a vast area. Just as a heat wave on land stresses people and crops, a marine heat wave stresses the life in the sea. Fish that need cooler water move, seeking depth or higher latitudes to escape the warmth. Species that cannot move fast enough suffer. The whole community of the upper ocean, from the smallest drifting plants to the fish that feed on them, shifts and strains under the heat. That shifting reaches human life through the fishing grounds. Off the coast of South America, the normal upwelling of cool, nutrient-rich water is what feeds one of the world's great fisheries. El Niño shuts much of that upwelling down. The warm surface water caps the cold water below, cutting off the nutrients that feed the whole food chain there. Fish populations thin or move, and the fishery that so many livelihoods depend on falters. This is not a new discovery. It is the very effect that South American fishermen noticed centuries ago, the warm current at Christmas that emptied their nets. The name El Niño was born from exactly this. There is another underwater consequence that touches people more directly than reefs or distant fisheries, and it appears along coastlines closer to home. Warm ocean water can encourage the growth of harmful algal blooms, dense growths of certain microscopic algae that release toxins into the water. Past El Niño events have enhanced these blooms along parts of the western coast of North America. When they occur, they can poison shellfish, sicken marine life, and force the closure of fisheries and beaches. It is a quiet hazard, easy to overlook, but a real one for coastal communities. The reason to give the ocean its own chapter is that its damage runs ahead of the lands and lingers behind it. The reefs bleach while the winter storms are still forming. The fisheries falter while the drought maps are still filling in, and the recovery at sea can take far longer than a season. A bleached reef, if it survives at all, may need years to regain its health. A shifted fishery may not return to its old grounds for a long time. The ocean absorbs the first blow and heals the slowest. The honest caution applies at sea as on land. The severity of the bleaching, the reach of the marine heat wave, the extent of the blooms, all depend on how warm the water actually gets and how long it stays warm. A more moderate event does less harm below the surface, a record warm one does more. So the ocean's fate this year, like the land's, rides on the question of the event's true strength, the same open question that shadows the whole story. The ocean's suffering is not separate from human life. It reaches us through empty nets and closed beaches and lost livelihoods. And the ocean is not the only place where El Niño's weather crosses into human health. On land, the shifted rains and rising heat carry their own consequences for the body, and those deserve a plain and careful look. The shifted rains and the rising heat do not stop at the edge of human health. They cross into it, in ways that are well documented and worth understanding plainly. This is a place to be especially careful and calm, because the subject is real but easily overstated. The link between a strong El Niño and human health is genuine. It is also manageable, and understanding it is the first step to managing it. Begin with the clearest link, which runs through water. In the regions where El Niño brings heavy flooding rains, standing water can follow, and standing water breeds trouble. It becomes a home for the mosquitoes that carry certain diseases, and it can contaminate drinking water with the germs that cause others. The great event of the late 90s showed this vividly. The flooding rains it brought to East Africa were followed by an outbreak of a mosquito-borne illness in the region, as the standing water gave the insects room to multiply. It is a direct chain: heavy rain, then standing water, then the diseases that water can carry. One specific illness illustrates the pattern well. In parts of East Africa that are sensitive to El Niño, cholera cases have been found to rise sharply during and after the pattern's heavy rains, with studies noting a threefold increase in affected areas. Cholera spreads through contaminated water, so when floods overwhelm sanitation and mix clean water with dirty, the disease finds its opening. This is not a mysterious or exotic risk. It is the old, understood danger of what happens when floodwater and drinking water meet, amplified by the extra rain a strong El Niño can bring. The dry side of the pattern carries its own health burden, quieter but no less real. Where El Niño brings drought and failed harvests, the threat is to food and water security. Thinner crops mean less to eat and higher prices, and in the most vulnerable places that can tip toward hunger. The weakened monsoon across South Asia, or the drought across southern Africa, is not only an agricultural story, it is a human one, measured in the strain on families who depend on the rain for their food. History's most extreme reminder is grim. Before modern forecasting, a great El Niño in the 1870s contributed to a famine that killed a staggering number of people across several continents. That was a different world, far less able to see the event coming or to move food to where it was needed. But it stands as a mark of how far the reach of this pattern can extend when the rains fail across too much of the world at once. Then there is the heat, the outcome this whole report keeps returning to. Sustained high temperatures are a direct health matter. They stress the body, and they are most dangerous for the very old, the very young, those who work outdoors, and those without access to cooling. As El Niño lifts the global temperature and deepens heat in many regions, the risk of heat stress rises with it. This is among the most widespread health effects of all, because the heat, unlike a localized flood, reaches so much of the world. Now the calm that this subject demands. Every one of these risks is known, studied, and to a large degree manageable. Aid agencies watch El Niño forecasts precisely so they can prepare, moving supplies and readying responses before the rains or the drought arrive. That months of warning, which the world now has, is exactly what turns a potential health crisis into a manageable one. The disease outbreaks of the past struck populations caught unaware. Forewarned, the same regions can act, and often do. The guidance for individuals is the plain, standard kind that public health officials give. In flood-prone areas, treat or boil water when its safety is in doubt after heavy rain, and heed local health advisories. In heat, stay hydrated, seek cooling during the hottest hours, and check on the neighbours most at risk. In drought-stressed regions, the response is larger than any individual, resting on the water and food planning that officials undertake. None of this is cause for fear. It is the ordinary, effective work of preparation, made more valuable by the warning a forecast provides. Health is one cost of a strong El Niño, money is another, and the two are linked, because failed harvests and flooded towns and closed fisheries all carry a price. That economic toll, which stretches far beyond the event itself, is the next thread to follow. The costs of a strong El Niño are not only counted in rain and heat and health, they are counted in money too, and the sum can be staggering. This is worth laying out plainly, because the economic toll is one of the clearest measures of just how far a Pacific warming reaches into ordinary life, and one of the most surprising in its size. Return to the number from the great event of the late 90s because it anchors the whole discussion. Researchers who studied that event's economic aftermath estimated the global income losses linked to it in the trillions of dollars, with one careful study placing the figure near 5.7 trillion. The event of the early 80s, by the same line of research, was tied to losses of several trillion as well. These are not the costs of a single disaster. They are the summed drag on the world's economies, spread across many countries and many years, that the researchers traced back to the disruption those El Niños caused. The size of those figures surprises people, and the surprise is worth unpacking, because it reveals how the cost is built. An El Niño does not send a single bill. It raises the cost of countless things a little, across a huge span of the globe, over a long stretch of time. A failed harvest in one country raises food prices there and in the places that trade with it. A drought idles a hydropower dam, so electricity costs more. A flood destroys roads and homes that must be rebuilt. A fishery collapses, and the people who depended on it lose their income. Each effect is a thread, and the trillions are what you get when you add up all the threads across all the affected regions. One striking example from a recent event shows the mechanism in miniature. During a past strong El Niño, drought lowered the water level at a great dam in southern Africa that supplies much of the electricity for two nations. Less water meant less power, and the shortfall rippled through those economies, slowing industry and daily life. That single dam, drained by a single drought, is a small picture of the larger truth. El Niño's costs flow through the systems people depend on, the water and the power and the food, and when those systems falter, the whole economy pays. There is a feature of these costs that makes them heavier than they first appear. They linger. A study of past events found that a strong El Niño can drag on a country's economic growth for years after the warm water itself is gone. The harvest recovers slowly. The rebuilt infrastructure takes time and money. The lost momentum is not regained in a season. So the economic shadow of a strong El Niño stretches well past the event, much like its heat, working through the world's economies long after the ocean has cooled. The bill comes due over years, not weeks. Not every effect is a loss, and honesty requires saying so. Some regions and some sectors benefit from an El Niño's shifts. A milder winter in the northern United States lowers heating costs and eases travel. A wet winter that eases a drought can help farmers who are struggling with dryness. A quieter Atlantic hurricane season spares coastlines expensive damage. So the ledger is not all red. The pattern redistributes fortune as well as weather, helping some even as it hurts others. The trillions in losses are a net figure across a world of winners and losers, weighted heavily toward loss because the harms tend to outweigh the gains. The reason to understand the economic toll is not to alarm but to justify the preparation. The cost of getting ready for a strong El Niño, of storing water, readying aid, planning for the season, is small against the cost of being caught unprepared. That is the whole logic behind the months of warning the world's forecasters provide. Every dollar and every action spent in advance can save far more later. The economic history of these events is, in the end, an argument for taking the forecast seriously and using the lead time well. All of this, the heat and the rain, and the health and the money, rests on a forecast, and a forecast is not a certainty. So before this report reaches its close, it is worth gathering the honest uncertainties in one place. What could still change, and what signals will reveal which way the event breaks, is the next and nearly final thread. Everything in this report rests on a forecast, and a forecast is a statement about the odds, not a promise about the outcome. So before the closing, it is worth gathering the honest uncertainties into one clear place. Knowing exactly what is not yet settled is as valuable as knowing what is, because it tells you what to watch and how much weight to put on each part of the outlook. The largest uncertainty is the peak strength, and it cannot be resolved until it happens. Forecasters put the odds near 2 in 3 that this event crosses into very strong territory by winter. That leaves a real chance it falls short and peaks as something merely strong or moderate. And at the other edge, a handful of models see it reaching for the strongest event in over 70 years. The truth is that no one will know the true peak until the ocean reaches it. Every El Niño has surprised its forecasters at least a little, running hotter or cooler than the models drew. So the single most important number in the whole story, the height of the peak, is also the one held most loosely. The second great uncertainty is the one this report has returned to again and again. It is the gap between the ocean and the atmosphere. The water may run record warm on the raw gauge, while the adjusted gauge, which strips out the background ocean warming, shows a more moderate pattern. The weather the world actually feels depends on the atmosphere's response, and that response may come in weaker than the raw ocean number advertises. So even a record on paper could deliver less than record-breaking weather on the ground. Which gauge the season follows, the alarming raw one or the calmer adjusted one, is not yet known, and it may be the most consequential open question of all. From those two central uncertainties flow all the regional ones. Whether California gets its wet winter or underdelivers, whether the southern drought eases or the rains fall short, whether the monsoon comes in weak or merely below normal. Each regional forecast is a tilt in the odds, and each rides on the two big questions of peak strength and atmospheric response. A strong responsive event sharpens every regional tilt. A muted one blurs them all. So the regional maps in this report are drawn in pencil, not ink, correct in their direction and uncertain in their force. Given all that, what should a person actually watch in the months ahead? A few signals will reveal which way things are breaking. Watch the monthly updates from the official forecasters, issued on a regular schedule, because each one refines the peak forecast as the ocean shows its hand. Watch whether the raw and adjusted indices continue to diverge, because their gap is the key to how hard the weather will land. Watch the first real test of the pattern as fall arrives, when the seasonal effects begin to show whether the atmosphere is responding strongly or weakly, and watch the ocean heat itself, whether the deep, warm pool keeps feeding the surge or begins to run dry. Those are the tells, and they will speak more clearly with each passing month. There is one more uncertainty worth naming, because it is the honest frame around all the others. The world is warmer than it was when the older giants formed, and that warming is changing how these events behave and how well they can be predicted. The rising baseline complicates the gauges, as this report has shown. It may also be shifting the patterns themselves in ways still being studied. So this event is not just another entry in a long, well-understood series. It is one of the first great El Niños of a distinctly warmer world, and part of what forecasters are watching for is simply how it behaves in these new conditions. That too is something no one can fully predict yet. None of this uncertainty is a reason to dismiss the forecast. A 2 in 3 chance of a very strong event is a serious lean, worth every preparation. The uncertainty is a reason to hold the specifics loosely while taking the direction seriously. The direction is clear. A strong El Niño has formed, the world will likely warm, and the pattern will tilt the odds toward floods and droughts around the globe. The specifics will fill in as the season unfolds. That is nearly the whole of it. What remains is to gather the story into its plainest form, to say clearly what is known and what is not, and to point toward the next thing to watch. So here is the whole of it, gathered into its plainest form. On a day in June of this year, the world's forecasters confirmed that El Niño had formed in the tropical Pacific. The warm phase of the Great Ocean pattern had arrived, and it was still gaining strength. That much is not a forecast. It is a measured fact, taken from a box of ocean watched by buoys and satellites, confirmed by the winds overhead beginning to move with the water. El Niño is here. That is where the story began, and it remains the firm ground under everything else. What is known beyond that arrival is a matter of setup and odds. The ocean went into this event loaded with heat, a deep, warm pool on the western side rivaling what preceded the strongest El Niño ever measured. That stored heat is real and measured, and it is why a large event is on the table. The odds favour this growing into a very strong event by winter, better than a coin flip, though not a certainty. And the world it is warming was already running hot, so the surest outcome of all is heat, a lift in the global temperature that is very likely to make this year among the warmest ever recorded, with the peak of that warmth spilling into the year that follows. What is not known is nearly as important, and holding it honestly is the point of a report like this one. The exact peak strength will not be known until the ocean reaches it. The gap between the record warm raw ocean and the more moderate adjusted pattern means the weather may not hit as hard as the water temperature suggests, and every regional effect, the wet winters and the droughts and the shifted storms, is a tilt in the odds rather than a certainty. It's force riding on how strongly the atmosphere chooses to respond. The direction of this event is clear. Its magnitude is still being written. Set the certainty and the uncertainty side by side, and the shape of the thing comes into view. A strong El Niño is formed and will very likely warm the world and tilt the global odds toward extremes. That is the certain part. Exactly how strong, exactly where the rains fall and fail, exactly how hard the atmosphere leans into the pattern, those remain open. This is an event to respect and to watch, not to fear. The months of warning the world now holds are the most valuable thing about it, because warning used well is what turns a hazard into something a person and a community can meet. That is why the quiet outcome deserves the last word, the one the title pointed to from the start. When people imagine El Niño, they picture a flood or a storm, a single dramatic blow that lands somewhere far away. But the outcome that is most certain and most widely shared is not dramatic at all. It is the steady heat, the lift in the baseline that touches nearly everyone and announces itself least. That is the outcome that is easy to be unready for, precisely because it is quiet. A warm ocean pulls the whole planet's temperature up along with it, and it does so whether or not any single storm arrives. The next thing to watch is simple to name. The official forecasters issue their updates on a regular schedule month by month, and each one will sharpen the picture. As fall arrives, the first real tests of the pattern will show whether the atmosphere is responding strongly or weakly, whether the alarming raw ocean number or the calmer adjusted one is the better guide to the season. That is the fork in the road, and it will reveal itself in the months just ahead. Watching those updates is the most useful thing anyone following this can do. For now, the ocean has changed state, the change is real and measured, and it is expected to deepen. The world has its warning, and it has the time to use it. This report will follow the event as it develops, and return when there is more worth telling. Until then, stay aware, stay calm, and keep an eye on the Pacific.